Question number 18, we're asked to find points of inflection, minimum, maximum points. So I'm going to highlight those main ideas on the graph right away. This point here, wherever I determine that it is, that is going to be a maximum point. And in the position that it's in, it's a relative maximum. I'm not sure they're even using that terminology, but we did when we studied this. This is relatively the highest point in the graph in a small area. There's a point right here. This is our point of inflection. There are a couple ways that you can remember a point of inflection. One is when your curve doesn't change shape, but it goes from fast to slow. So it's kind of like a speed bump in your graph, but never changes its direction. So it's decreasing the whole time, but it is a fast rate of change, slow, fast. Where it transitions from, another way we described it as a concave up graph to a concave down graph, there's a point of inflection. So I know I have a point of inflection, and then I also have another third characteristic right here, and this point is a minimum. And in our discussion, again, we call it a relative minimum because it's not an absolute, because it goes down forever. So I'm looking for those characteristics in the best of our ability, trying to figure out where those things are happening. So this looks like it's at a half. So they used a decimal, so 0.5, and it looks like it's at a 7. We should have a maximum. So that looks like it's in the running, and that's in the running. I know I have a point of inflection, and that point of inflection happened at 2:1. So now I already know that B is the correct answer, and we better have a confirmation that there's a 3.5, which is confirming that at 3.5, -5, yeah. So it's letter B. So just reviewing a few concepts of maximum, minimum, and a point of inflection with question number 18.